Okay, so now in section 5.4, we're going to be taking what we know about angles and talking about how to solve right triangle problems and applications. So there is a worksheet for this, but before we get to the worksheet, let's do some baseline information. So we're going to be talking about solutions and applications of right triangles. All right, so first of all, when we're labeling a triangle, or let's labeling a right triangle, it's going to look something like this. Where the angles are going to be capital letters, and the sides are going to be lowercase letters. So we'll label this angle A, this angle B, this angle C, and side A is going to be opposite angle A. Side B is going to be opposite angle B. And side C is going to be opposite angle C. So the angle creates the side. That's how we label a right triangle. When we go to solve these problems, regular trigonometry is used to find a side and we'll use inverse trigonometry to find an angle. So let's take a look at a few problems. I'll get this worksheet just kind of out of the way for now. We'll come back to this in a little bit. So let's solve the following triangles. All right, and we'll do two. So in our first triangle, angle A is going to be 34 degrees, angle C is going to be 90 degrees, and side C is going to be 12.7. So let's go ahead and draw a triangle. Now be careful how you label it. We know the right angle is angle C. Doesn't matter what we put angle A and B as. We know angle A is 34 degrees, angle C is 90, and side C is 12.7. So usually whenever I solve a triangle problem, I just get organized so I could see exactly what I'm missing. Angle C is 90 degrees, angle A is 34 degrees, and what else do we know? Side C is 12.7. Okay, so let's figure out what we're missing here. Well, we don't know angle B, so all the angles in a triangle add up to 180. I'm going to do 180 minus 34 and 90. Let's see what that is. 180 minus 34 and 90. That's 56 degrees. So I'll label this here. And now let's find the side. So you have to make a decision which side you want to find. We have a lot of freedom here, and we'll use our trig functions to do this. Let's say I want to use angle A, because I know angle A is 34. I could use the hypotenuse to find the opposite using sine. I could set it up like this. The sine of 34 degrees is equal to side A over 12.7, and then I can make a proportion and solve for side A. I could also use the cosine of 34, and that would give me side B over the hypotenuse, and I could cross multiply to figure that out. I could also use 56 and do a similar process. So we have a lot of different options here. I'm going to go ahead and use this first option that we mentioned. If we cross multiply, we get a is equal to 12.7 times the sine of 34. And if we type this into our calculator, 12.7 times the sine of 34 degrees, my calculator is telling me that this is 7.1. And if we know that that's side A, we could use Pythagorean Theorem to find the missing side. Or we could just use the trigonometry. It doesn't matter how you do it. So if you want, we could do this, and this will tell us what side B is. I'll also use Pythagorean Theorem, and you'll see we'll get the same answer. Cross multiplying would give us B is equal to 12.7 times the cosine of 34. And if we type that in, 12.7 times the cosine of 34, that gives us 10.5. We could have also gotten that using Pythagorean Theorem. So if we know 7.1 is A, and we want to find out what B is, it's going to equal 12.7 squared. So if you do some basic algebra here, 12.7 squared minus 7.1 squared, get B squared is equal to 110.88, and B would equal the square root of that is 10.5. You get the same exact answer. So we have a lot of freedom on how we could do this. Our answer would be these 6 components of our triangle. Let's do another problem. How about if we had something like this? Let's say we had angle C is 90 degrees, side A is 29.43, and side C is equal to 53.58. So angle C is the 90-degree angle, and it doesn't matter which one we pick for A and B. We know side A is 29.43. We know side C is 53.58. So let's get set up over here. I'll write down what I know. And now let's go to work. First thing we could do is we have 2 sides of a right triangle, so let's just use Pythagorean Theorem to find side B. If A squared plus B squared is equal to C squared, and A is 29.43, let's do this here, so 53.58 squared minus 29.43 squared. This comes out to 2004. It was a good year. 0.7. So if we take the square root of that, we get B is equal to 44.8. All right, so now we have to figure out an angle. If we just get one angle, we could subtract them from 180 and get the other one. So I'm not going to use 44.8 because that's a rounded number. I want to try to use this side and this side. So we could either use angle A or we could use angle B. If we use angle A, what trig function has the opposite side and the hypotenuse? Sine. And we want to figure out what A is. So what we could do is we could actually take what's called the inverse sine. It's the button right above sine of both sides. And what this will tell us, inverse sine of 29.43 divided by 53.58. And that gives us angle A is 33.3 degrees. And if we do 180, minus 90, and 33.3. That tells us angle B is 56.7. Another option we could have done, if you don't want to use angle A, is we could have done angle B. And if we do angle B, we have to use the side adjacent to it over the hypotenuse. So that would be the cosine of angle B would equal 29.43 over 53.58. So if you take the inverse cosine of both sides, you'd get 29.43 divided by 53.58. Comes out to 56.7, the same thing. All right. So I know sometimes people just want to know one way to get an answer, but with trigonometry, often there's multiple ways to get to the same answer. So this would be the answer right here, all 6 components. We are going to take a look at an applications worksheet, but before we do, I just wanted to explain a little bit about what's called angles of elevation and depression. So let's base it on a person looking straight ahead. If a person's looking straight ahead and he's looking at like a bird in the air, I can't draw to save my life, so pretend that's like a bird. This angle right here is called the angle of elevation. And then let's say there's a lake in front of them and there's a fish. I could draw a fish and he's looking at the fish here. This angle right here is called the angle of depression. So it's important that we understand those phrases. So now let's take a look at our worksheet. This could be found in the supplemental materials. All right, so the first one is based off of a real life example. If there's a large tree outside of your house, during a recent storm, you notice several trees in your area are toppling over. If your house is 123 feet from the base of the tree and you use a device to find the angle of elevation to the top of the tree, we have like a few different questions. Okay, so here's a tree. Okay, and here's your house. Okay, your house is 123 feet from the base of the tree. And we use a device to find the angle of elevation to the top of the tree. So we have a right angle right here, is 26.6 degrees, and we're looking to find the height. So what trig function uses an adjacent side and an opposite side? Tangent. So if we use the tangent of 26.6, that would equal the height of our tree divided by 123 feet. And if we cross multiply, we'd get the height is equal to 123 times the tangent of 26.6, which tells us that the height of the tree, 123 times the tangent of 26.6, is 61.6 feet. If it were to topple, were to damage your house, no. I mean, 66 or 61 feet would be like over here if it fell down. So the house is safe. Okay, let's take a look at number 2. So for number 2, from the top of a 210-foot cliff, Juan observes a lighthouse that is 430 feet offshore. Here's a cliff. Here's Juan. The cliff is 210 feet. The lighthouse is 430 feet. And this is like water. and here's the lighthouse. I can't draw here, so there you go. Everyone knows that's a lighthouse. Find the angle of depression from the top of the cliff to the base of the lighthouse. So here's our triangle. Now remember, if you look straight ahead, this would be our angle of elevation. So that angle and that angle are complementary. So you have to be careful here. So let's find the fish angle first. That's called alpha. So alpha, we would use the opposite side and the adjacent. So the tangent of alpha is equal to 430 over 210. And if we want to get an angle, we use inverse trig. If we take the inverse tangent of both sides, we get the alpha angle, inverse tangent of 430 divided by 210, comes out to 64 degrees. And theta would equal 90 degrees minus 64 degrees, which is 26 degrees. That would be our answer. So it's important that you understand how to work with just angles of elevation and depression. A lot of people, common mistake is they would give like what this angle is, or they would do inverse tangent and come up with this angle, but that's not what we're looking for. We want the angle of depression. Let's go to number 3. For number 3, during the Super Bowl, an airplane is flying 10,000 feet above level ground. The angle of depression from the plane to the stadium is 13.8. How far horizontally must the plane fly to fly directly over the stadium? Okay, so let's draw a really bad picture here. Here's a plane. And it's clearly a 747. There's a little bump on top. It's really bad. So please forgive my lack of artistic ability. But the plane's flying, right? And the plane is 10,500 feet above the ground. The angle of depression from the airplane to a stadium. Remember, angle of depression, we look straight out and then go down. So this is 13.8 degrees. How far horizontally? That's what the question is. How far horizontally must the plane fly to be directly over the stadium? And the stadium looks like it would be over here. Here. It's like a Penn State stadium. All right. So here's one thing, that could help us. The angle that we're using here, this line that's going straight, is actually parallel with this line. So one thing we could do is we could use what's called alternate interior angles. It'll save us a step. If this angle is 13.8, then that means this angle is 13.8 degrees. You learned that in geometry class. You don't have to do that. I mean, technically, you could find the complement, get what this angle is. That would be the complement. So 90 minus 13.8 is 76.2. And then you could use that angle to figure out what x is. So we have a few different options. If you use alternate interior angles, this is how you set it up. I'm going to use the tangent of 13.8 is equal to 10,500 over x. If you cross multiply, we get 10,500 is equal to x times the tangent of 13.8. And if we divide by the tangent of 13.8, we get that x is equal, let's see here, 10,500 divided by the tangent of 13.8 is 42748.3. So 42,748 feet to go. That's if we use alternate interior angles. If you wanted to use the 76.2, we could still get the same answer. What we would do is we would say the tangent of 76.2 degrees is equal to x over 10,500. So it's set up a little bit different. Not a big deal here. If you cross multiply, you get x is equal to 10,500 times the tangent of 76.2, and you'd get the same exact answer. So we have a few different ways to handle this. Now for number 4, I remember doing this when I was in middle school. You shoot toy rockets up into the air, and whoever rocket goes the highest gets like an A or something like that. So let's take a look. Middle schoolers shoot off toy rockets in wood shop. Paul stood, so here's Paul. He stood 100 feet away from a rocket, and the angle of elevation to his rocket was 60 degrees. Here's a rocket. Okay, so how high did his rocket go? Well, we're going to be using tangent. The tangent of 60 degrees here would equal the height over 100. If we cross multiply, we get the height is equal to 100 times the tangent of 60, and the height would be 100 times the tangent of 60 is 173.2 feet. Now let's see Jenny. Jenny stood 150 feet away, so she's a little bit more careful than Paul is. Her rocket goes up. Here's her rocket. And her angle of elevation was 55 degrees. So how high did her rocket go? Well, same idea. The tangent of 55 degrees is equal to the height over 150. If we cross multiply here, we get the height is equal to 150 times the tangent of 55. Let's see what this is. 150 times the tangent of 55 is 214.2 feet. So it looks like Jenny won. All right, so those are some applications with right triangles.